So, good morning, everyone. Today, I will take one more new video related to JEE mains. We already know 24th June, 24th of June 2022, first phase mains started. So, in that first phase mains, 24th, shift 1. What type of questions are coming in chemistry related, I will discuss now. Now, the first question, one of the question, different slots, different sequence of the order is there. One of the question, difference in the oxidation state of chromium in chromate and dichromate. Difference in the oxidation state of chromium in chromate and dichromate. Let us take the first question, difference in the oxidation state. Yes, we know chromate formula CrO4 2 minus. Chromate formula CrO4 2 minus. Whereas the dichromate formula Cr2O7 2 minus. Find the oxidation state of chromium. Let us assume chromium oxidation state is X. We know oxygen is -2. 4 into -2 is equal to -2. Then oxidation state of chromium here +6. Whereas dichromate, to calculate like this, here oxidation state of chromium is again +6. Therefore, the change in oxidation state in chromate and dichromate is 0. Why this question is given? Generally, all members know the oxidation state, why this question is given. This is a very logical point is there in D block. One name is manganate and permanganate. Manganate and permanganate. In manganate, MnO4 2 minus. Permanganate, MnO4 minus. So those members who already studied manganate and permanganate ions, therefore that students confused about chromate and dichromate formula. In manganate, manganese oxidation state is +6, whereas permanganate, manganese oxidation state is +7. That means two different oxidation state in manganate and permanganate. Like that, all students confused about chromate and dichromate. If you know the formula, yes, it is dead easy. But the majority will think like this: manganate and permanganate different oxidation state. Therefore, chromate and dichromate also different oxidation state. No, both have same oxidation state, but the difference is here one chromium, here two chromium. That is the difference, and very important. Both are tetrahedral structure. Very important. Both are tetrahedral structure. Okay, now for this question the answer is change in oxidation state of chromium in both the cases is 0. +6 minus 6, it becomes 0. Yes, question number 2. Which cation will give deep red color precipitation with DMG reagent in basic medium? This is the most familiar example to identify the cation nickel +2. Nickel +2 gives a deep red color precipitation with the DMZ. First of all, DMZ is nothing but dimethyl glyoxamate. So dimethyl glyoxamate is a monodentate ligand, bidentate ligand. So we know glyoxal. CH double bond, no double bond O. This is called glyoxal. Dimethyl. So in place of CH3, we take CH3. Dimethyl. Glyoxime. When aldehyde react with NH2OH, it forms oxime. That means here NOH is there. NOH is there. This is called dimethyl glyoxime. So, but DMG means dimethyl glyoxamate. That means lose one H plus from this one. This is called O minus. This is O get, one is negative charge. So therefore, finally, the very important in DMG related very important information. Of course, the question is which cations gives a deep red color precipitation with the DMG means 100% nickel plus 2. But some more concept is related to DMG I can introduce now. Dimethyl glyoxamato is a bidentate ligand. It is a bidentate ligand. It is a bidentate ligand. And one more important, it has uni-negative charge. Uni-negative charge. One uni-negative charge. So therefore, we are combined with the nickel. Yes, it forms the complex NiDMG. Take twice NiDMG now. That is a very important point. So here NiDMG taken twice. So if you take NiDMG taken twice, this is NiDMG, dimethyl glyoxamato, taken twice is there. So in that DMG taken twice, take that Nana. Very important point here. The top of the complex is 0. That means it is a neutral complex. First point, it is a neutral complex. Complexes are 3 types depending on charge. Cationic complex, anionic complex, neutral complex. So here DMG, the top of the complex square bracket, there is no charge. So it is a neutral complex. Majority think that nickel plus 2 is there, then it is a cationic complex. No. DMG has -1 charge each DMG, like X minus. So X, nickel oxygen state, suppose X -1, 2 are there, so -2 is equal to 0, then oxygen state is +2. Here nickel oxidation state is +2. Very important point. Here nickel oxidation state is +2. And DMG, we know DMG nickel configuration 4s2 3d8 in ground state. In nickel +2 means 4s0 3d8. Here electrons pairing take place. Therefore one orbital is vacant. So therefore the hybridization is dsp2 hybridization, square planar arrangement, and it is very important, it is diamagnetic. How many unpaired electrons in 3d8 if electrons are paired? No unpaired electron, so it is diamagnetic. Very important, it is diamagnetic complex and no unpaired electron, square planar, dsp2. So finally this is the answer, nickel +2. Next question. In CO2, CO taken 8 times, metal carbonyl. In CO2, CO taken 8 times, metal carbonyl. In this compound, number of CO bonds, metal bonds is taken as X, and number of terminal CO is taken as Y. Then X plus Y is equal to how much? Then here number of terminal CO bonds 3, and here 3. Total terminal CO bonds 6 are there, and one CO metal bond 1 is there. So X is 1, Y is 6. Then X plus Y is equal to how much? 7. Now very important in this metal carbonyl, NiCO taken 4 times, metal carbonyl. Related to metal carbonyl, what is the bonding between metal and carbonyl? I am already, one video is done in the previous my channel only. Okay, so look at this very important structure between CO and CO. Metal bond is there, and terminal COs 6 are there, middle COs also 2 are there. Now very important observation, we look at this 3 questions from the first 3 questions we are observed. All are related to D block and coordination chemistry. That means inorganic chemistry, D and coordination chemistry is a very important lesson for mains point of view. Okay. Next question, question number 4. Among the following oxides, number of amphoteric oxides. Amphoteric oxides. Yes, it is next question number. Next question. Among the following oxides, how many oxides, number of oxides having amphoteric nature? This is a very important question. Actually, here the given oxide is, one is Na2O, another one is arsenic oxide As2O3, and another one N2O and NO. These are the given oxides. So regarding this answer, yes, the only one oxide is there. We know sodium is a metal. Metal oxides are basic. Arsenic is a metalloid. Metalloid oxides are amphoteric. Nitrogen is a non-metal, but even though it is non-metal, these two oxides are amphoteric. Sorry, these two oxides are neutral. N2O and NO are the neutral oxides. As2O3 is a amphoteric oxide. So in entire all oxides, in carbon family, carbon, silicon, germanium, tin, lead is there. So germanium is a metalloid. In nitrogen family, nitrogen, phosphorus, arsenic, antimony is there. Arsenic, antimony are the metalloids. In oxygen family, oxygen, sulfur, selenium, tellurium is there. So tellurium is a metalloid. So that means metalloid oxides are amphoteric. That is one important question. Metalloid oxides are amphoteric. So for that question, in metalloid oxides are amphoteric. What are the metalloids? Germanium in 14th group, arsenic, antimony in 15th group, tellurium in 16th group. These are the metalloids. Metalloid oxides are amphoteric. There is no ambiguity. Generally, metal oxides are basic. Non-metal oxides are acidic. Metalloid oxides are amphoteric. Even though some elements are metals, but their oxides having amphoteric nature. That means having basic nature and also have acidic nature. What are that? Beryllium is a metal, but oxide is amphoteric. Aluminum is a metal, but oxide is amphoteric. Zinc is a metal, but oxide is amphoteric. Chromium is a metal, but oxide is amphoteric. But chromium not all oxides. Cr2O3. Cr2O3 only amphoteric oxide, whereas CrO3 is acidic oxide. PbO to both. This is very, very important. Lead oxide, flumbus and flumbic. PbO and PbO2 both are amphoteric. SnO2 both are amphoteric. These are the amphoteric oxide in throughout your lessons. Okay na? Next, question number 5. This is given matching. Like advanced bits, here it means matching is given. The matching is also very easy question. This is also related to both inorganic lessons, very important lessons. That is, one is chemical bonding, another one coordination chemistry. Very important lessons. Excellent. Correct? Yes, in inorganic chemistry, ultimate lessons, one is the major role. Throughout inorganic chemistry, one is chemical bonding, another one is coordination chemistry. Very good lessons. Both related bit, this related hybridization, simple bit hybridization. BRF5, what is the hybridization? We know bromine is a 17th group element. That means 7 valency electrons are there. 5 only bond. That means 1 lone pair. 1 lone pair, 5 bond pairs. 1 lone pair, 5 bond pairs. Total 6 hybrid orbitals are required. That is sp3d2 hybridization. BRF5. Whereas PCl5, 15th group element, 5 valence electrons are there, 5 are in bonding. 5 are in bonding, no unpaired electron, no lone pairs are there. So 5 sp3d. This is the excellent complex, cobalt ammonia complex. Cobalt ammonia complex with plus 3. Cobalt plus 3 complexes and cobalt plus 2 complexes, that story is very, very important. Cobalt plus 2 with ammonia, cobalt plus 3 with ammonia, both will change hybridization. Due to the high nuclear charge of cobalt plus 3, due to the high nuclear charge of cobalt plus 3, here ammonia acts as a very strong ligand and rearrangement take place and involved hybridization is a D2sp3 hybridization. D2sp3, cobalt plus 3 with ammonia ligand. Not only with ammonia, very good information. Cobalt plus 3 has high nuclear charge. A moderate ligand like water, a moderate ligand like oxalate, ethylene diamine, ammonia. In all the cases, cobalt plus 3 involves electron rearrangement take place like very strong ligand. So therefore it involves D2sp3 hybridization. I think this is well known. What is the meaning of sp3d2 and d2sp3? D2sp3 means inner orbital. Inner orbitals are involved in bonding. Inner orbital means 3d orbitals of nickel, 4s and 4p orbitals of nickel. Outer is 4s 4p, inner is 3d kada. So therefore, due to the electron rearrangement, cobalt plus 3 complexes with ammonia, water, oxalate, En, cyanide, all complexes involve D2sp3 hybridization, but not cobalt hexafluoride, COF6 3 minus, in which also cobalt plus 3, but here the pairing not take place. Fluoride and Baker ligands, hybridization is sp3d2. Fluoride and above, strong ligands, moderate ligands act as a strong ligand due to high nuclear charge of cobalt plus 3, D2sp3. And the platinum, excellent bit. Whatever may be the halogen, either chlorina, bromina, iodina, fluorina, or in place of chlorine we take cyanide, whatever it is. All platinum plus 2 complexes due to the high nuclear charge, here also same reason, due to the high nuclear charge of platinum plus 2, here electron rearrangement take place. So then the involved hybridization is DsP2. All platinum and palladium plus 2 complexes with the coordination number 4. All platinum plus 2 and palladium plus 2 complexes with the coordination number 4 involve DsP2 hybridization. Okay, now enough.